anniversary celebration, and we've surpassed having 75,000 students and visitors. And we would not be able to do all this without our wonderful volunteers. We're an all-volunteer organization, so I'd like all the volunteers to stand up and wave.
They're tired.
And we are open most nights of the year, again, all with volunteers, and we have a collaboration with Berthoud High School, but the school district does not actually fund us. We are a separate nonprofit organization, and we aim to not only serve the students of Berthoud High School, but all of the surrounding school districts. So we have different grade schools that come and visit the observatory, and we also have special evening courses in astronomy for high school students. And those classes count towards graduation credit at all of the surrounding high schools and school districts. So if you know of somebody who's a high school student who might be interested in astronomy, please pass the information along, and if you want more details, please talk to one of the volunteers. And I think we have a volunteer training coming up soon, new volunteer orientation. 23rd. The 23rd.
Got moved. It's not this weekend.
Okay,
Yep.
So 2 weekends, and our own John Ensworth, who will give us an introduction, a science intro shortly, also does an astronomy science class regularly for our volunteers, and that's coming up.
Tomorrow morning.
Yep.
Yep.
So what we're going to do for this evening is to start off with John giving an introduction to
News update. Yep.
Yep. And then I will introduce our main speaker afterwards. So thank you, John.
Thank you. Yeah, we sort of penciled this out in the last hour or so, but we're going to do some tag teaming. So I'll be up, and I'll be down, then I'll be back up. And you know, I think you have 3 presenters tonight.
Yeah,
I think 3 presenters. So yeah, absolutely, 3 heads. Yeah. So I'm just going to do the first part of the little news update for this month, and that's the shape of the galaxy. Everybody knows the shape of the galaxy is a big, flat, round disk, right? No. So we have a warped home. So do I. But
we have a flat Earth society. Is there a flat galaxy
society? Yeah, see, and neither is the Earth. I got the joke in there too. Galaxy is not flat, says Dorada Skoran. What is it? Very nicely done. University of Warsaw, Poland. And what this team did, they looked at 2,400 Cepheid variables. Now these are stars that pulse. They change brightness like regular clockwork, and their brightness changing is based on their size. So their size also gives luminosity. So you can put all this together, you see a pulse of one of these Cepheid variables out there as far as you can detect it, and you know how bright it actually is in space. And once you know that, you can figure out how far away it is. So looking at the optical gravitational lensing experiment, OGLE, and 5 other surveys, they pieced together a better picture of distant portions of our galaxy. And it's hard to see through our galaxy. There's lots of gas and dust in the way. And I think they use near infrared too, so they're able to get further through the dust. They found there are 3 populations of 3 different ages of stars, and this is probably the shape that we see today in our galaxy is probably caused by an interaction with a smaller or dwarf galaxy that came by or through or has merged with us. So you can see this sort of bent Pringles chip shape here. And we have a little video where can see the actual stars that they mapped. And here's us, so if you want to know where you are, we're right at that spot. So Carol, go ahead and push play, if you would. And this will cycle through 3 times, so you can kind of watch where you are or your favorite part of the galaxy. Everybody has a favorite part of the galaxy, right? So you can see what your favorite part's doing. That is a pretty complex shape. And older studies also show that we probably have a bit of a bar in the center of our galaxy too, so sort of a barred spiral. They're not featuring that in this graphic. So we're a barred spiral that's kind of warped. Man, it's just not what I expected. All right, one more time for our galaxy here. You can see us rotate around. Some of these variables are off the plane, but you can see where the main clustering is.
There's a question, John.
Our question, yes.
Those are just the set variable stars.
Yeah.
There's all sorts of other stars like that.
There's a lot more stars than that, yeah. They're just representing those with a general shading, yeah. These are the actual data points that they use to determine this, yeah. All right, any other questions? All right, if you'll introduce Suzanne, I'll be back up for another part of this in just a moment.
Okay. Well, while we're swapping microphones and getting Suzanne up here, I have to make the other part of our spiel, which is, while we're an all-volunteer organization, we also rely completely on donations. So if you're one of the folks who want more money than time, we would graciously appreciate whatever might fit for you. Yeah, we'll help balance it out. Because most of the groups that come to visit are school groups, which the schools aren't able to donate in the same way. So if that is something that you could help with, in the back corner there is, by the door with the dollar sign on it, is our donations box. And you can also donate through online through our website as well. So we very much appreciate that, because all that we do here for operations is only possible through what everybody donates. So thank you so much for that.
Don't forget the stuff up there that's available for donation.
Yes, and we also have books and T-shirts and bookmarks and things available for donations as well. Thank you from our treasurer, Mark. Please make Mark happy. So any other questions about the observatory before we move on to our main presentation?
Ask how many people have been here.
How many people have been here before? Oh, lots of returning people, but how many people are here for the first time?
Yeah.
Oh, well, welcome.
Andrea, why don't you talk about the telescopes? Telescopes.
Yes, so we have 2 large telescopes. The first one that we got was the 18-inch telescope, which is in the dome over that a ways. And the first days of the observatory, you could see the blue line in the carpet right here. And this was where the observatory ended. There was the wall here. And the observatory was hand-built by the townspeople in Berthoud, and then later we were very fortunate to receive the donation of the Mount Wilson 24-inch telescope after it was retired. And that telescope, which is through this door and up in our second dome, was built commissioned by NASA to be built in support of the Apollo program to study the moon in preparation for the moon landings. So I hope that the clouds will clear so you get a chance to look through the telescopes tonight. But we're very proud of them. And once we got the second telescope donated, then once again our local townspeople came out again, and they took down this wall and expanded the observatory, basically just flip-flopped the construction plans. And then that also allowed us to to not only have our star wall with the Greek constellations, but to put, oh, you're really good at this.
I'm going to do Vanna White here.
Yes. The Lakota Native American constellations to represent the astronomy and how the sky was viewed by the people who were living in this area. So any other questions about the observatory? Okay, well, without further ado, let me introduce our featured speaker for tonight. We have Suzanne Metlay, who is one of our most wonderfully beloved speakers. I've lost count of how many
It's
times.
just because I'm frequent. I'm a pest. I keep coming back year after year. Can't get rid of me, so.
Nor would we want to. And Suzanne's background is that she studied at Harvard and then got her PhD in geology and planetary sciences from the University of Pittsburgh, and then got to do all kinds of interesting research, including in Antarctica. And then she has worked a variety of interesting positions in astronomy, including being the education programs director for Fisk Planetarium and working for the Secure World Foundation and teaching at Front Range Community College. And now she teaches at Western Governors University, which is not maybe as well known. It's a purely online observatory university, but it produces the largest number of K through 12 science teachers in the United States, and Suzanne is part of that program.
As are Ben and Andrea, so we have a contingent.
Me as of just a few weeks. Good job. Which I'm excited about. Yeah, so Suzanne, welcome.
All right, thank you, everybody. It is always a pleasure to be here and to see so many familiar faces, not only from WGU, but more importantly, from the Berthoud community, because these volunteers at LTO are some of the best, most heartfelt people you'll ever meet. They know their astronomy, and yeah, and you've all carried lumber for this place, right? So, I mean, really, it is an honor and a privilege to be here. And if you do want to make a donation to keep their programs going, that is a wonderful thing. I also want to shout out to all the new people. There are people here from Thornton and Erie and Fort Collins and Denver. And I just really appreciate your driving all over creation in order to come here. I know it's a little warm in here, so we may want to open the doors and let some ventilation in. You know, I'll let you guys decide. Okay. Okay, so I want you to feel free to interrupt me, okay? If you have a question, I'm going to stop every few slides and go, all right, let's talk about, or, you know, and I will bring John and my husband Mike up here because I do feel that listening to me for, I don't know, 45 minutes can get wearing. So let's bring in other voices, and that includes yours. So just one last pitch about Western Governors University. We just got our accreditation from a second national organization. Normally, a teacher's college, which is where I teach, gets accreditation from the Council for Accreditation of Educator Preparation Programs. It's called CAPE. But there's another organization called AAQEP, and please don't make me tell you what that all stands for, except the Q is for quality. Quality Educator Preparation, something like that. And so now we are fully accredited by 2 national organizations as well as all the regionals, because Western Governors University is nationwide. And we serve those students who are looking for their initial licensure in teaching, so people who want to become teachers at the K through 12 level. Plus, we have advanced programs, so people who want to be, to get their master's degrees, people who want to be principals, we teach those people as well. And Andrea is right, I and one other person are the Earth Sciences Department. We have an astronomy course, astronomy is an important part of our general education curriculum as well as our advanced programs, not only in Teachers College but elsewhere. So we are the #1 provider of earth science educators in the United States, and it's just a wonderful feeling to know we're putting good people in good schools in your communities. So I'm happy to talk to you about that afterward. Okay, commercial over. I wanted to talk today about the fact that lots of people are interested in going to the moon, not just the Americans who were there 50 years ago and want to come back. It's actually very, very competitive. And Ben, since you're standing right here, and I know you can hold a globe very high so everyone can see it, let's refresh your memory. Okay, now I'm not going to be able to reach. So no. I'm going to make Ben spin the globe. If you can please point out where is China. There we go. So there's China. Can you please point out where is India? Where is Israel? Yeah, exactly. And then where's the United States? Okay, thank you. And you can put the globe back. So you can see that space always has been international. Thank you very much, Ben. Space has always been international, but now it's really getting to be, well, I can't say crowded, there's plenty of room, but it's getting pretty interesting. So let me bore you with a little history. I promise there's only one history slide. And that is, you may not be aware of this, but most people in all of human history could only see one side of the moon. It was not until 1959, that's only 60 years ago, that we were able to see the other side of the moon, what we call the far side. Now, for all you Pink Floyd fans, this is not the dark side of the moon. It is the far side of the moon. It does get hit by sunlight every 14 days. And a day on the moon is 14 days long. So it's not dark. But it is really interesting. So in that decade, from 1959 to 1969, this was the height of what we call the Cold War, and the United States and the Soviet Union, which has become just Russia, were really, really competing. But at the time, the Soviet Union was more than Russia, and they had a lot of satellite states in Eastern Europe, and they and the United States were fighting over countries like India. So that's, India gets into this story actually pretty early. So the Americans and the Russians were competing, and the Russians were beating the pants off the Americans for the first few years. And then the tide turned, and the Americans started to win the race. And that space race ended with the last humans on the moon in 1972. And then there was this pause. Everyone was tired. They'd spent their budgets. They'd done their thing. And it was time to turn attention elsewhere. So the next time the moon got serious attention was, years later. In 1992, Japan said, hey, we're here. We can send something to the moon. And their Kaguya spacecraft gave us that beautiful image of Earth over the lunar horizon. And it's one of my favorite moonshots. They did a lot of good work, but they were by themselves until in the early 2000s, so about 15 years ago, the European Union, meaning all the countries of Western Europe, got together. They had formed the European Space Agency and said, we want to go to the moon. And obviously the Americans had other probes to the moon, like Clementine, but there wasn't a real push to go back to the moon until about 10 years ago, when China got itself together and said, well, we're going to the moon. And by this point, China had been excluded. China had not been allowed to participate in the International Space Station. Even if they had wanted to, the answer would have been no. The orbit of the Chinese space station right now is actually different from that of the International Space Station. So I'm sorry, those of you who saw the movie with Sandra Bullock called Gravity, right, where she just hopped from one station to the next, no, that could not possibly work. because they deliberately were told, no, you can't have this space, you have to have a different orbit around Earth, because we don't want to play with you, China. And China is now, well, now doing its own thing and feeling itself, as Beyonce would say. So India, not to be left out, remember I said India was a country fought over during the Cold War. In 2008, India said, well, if China can do this, we can do this. And they actually made some serious scientific discoveries with their Chandrayaan-1 spacecraft. And that now has led to a mission I will tell you about in about half an hour, called Chandrayaan-2. And Israel, of all places, very quietly was developing its own tech sector and said, you know what, we are a little country. We can't afford a big national mission, but there are some wealthy billionaires out there. And so there is an Israeli version of Elon Musk. His name is Morris Khan. He is a South African, just like Elon Musk. But instead of being a South African American, he's a South African Israeli who said, we're going to go to the moon. And he did get there, it just didn't soft land, it crash landed. I will tell you more about that because it's actually a fascinating story and we're not done. Okay, we're in the middle of the story, but it's an interesting one. So we have been fascinated with the moon for millennia, obviously. Humans always have stories about the moon. But in terms of actually going there and utilizing its resources and using it as a political pawn during the Cold War and now as an economic pawn, we're only just getting started. This is the beginning. Any comments? Anyone else have anything to chime in? Yeah, Ben.
Chinese rover on the far side of the moon, how do they get the signals back to the Earth?
We will get there.
Okay.
I promise. I promise. So this, and yes, we will have other private missions. We'll talk about that. Space is big business, by the way. And for those of you who were at my talk last year, I talked about Colorado's aerospace economy. And so we are an enormous chunk of this. So when we are talking about India and China, these are the non-US space budgets. That's about 10% of the total. The rest of this is pretty much based in the United States in one way or another. And yes, there's $400 billion for the first time. And those numbers will only go up. So this is one of the things that gets me excited, right? There has been, for the past 50 years, all sorts of human activity on the moon. And so the Chinese said, well, can we grow any plants? And the answer is yes. They planted cotton seeds. And as you can see, it started with germination, and 6 days later, we had a little stalk and some leaves, and it would have been just fine if they'd been able to keep it warm. But the way it works on the moon is each side of the moon that's lit up by sunlight is only lit up for about 14 days. And then it goes into 14 days of darkness. And those poor little cotton plants, they just froze to death. So they couldn't keep it warm enough because something like a heater would cost weight, and that means money. And they had their proof of concept. So of course the next thing is to see if they can get a grow operation on the moon, right? Once you are going to have people to tend these plants, now we know it can be done. The other interesting thing that got left behind on the moon actually just happened a few months ago. You're probably aware that 50 years ago, the Apollo astronauts had to leave stuff on the moon, right? They needed room and weight for the moon rocks and dirt that they were bringing back. So the Apollo astronauts jettisoned anything they didn't have need for. So garbage, and after a while, poop. So Apollo astronaut poop has been on the moon, perfectly preserved in bags, for 50 years. So added to that have been other spacecraft, with other interesting stories. There was a surveyor spacecraft that an Apollo engineer, not an Apollo, a NASA engineer sneezed on. And so we found out with the Apollo 15 mission, because they brought back Apollo 12, thank you. Yeah, he's my Wikipedia. They brought back a piece of the Surveyor 3 spacecraft and found that when they got this piece of metal back on Earth, the germs woke up again. Wow. So that got people thinking 50 years later. And so when Israel sent its spacecraft to the moon, it deliberately put DNA samples of various plants and animals so it would be on the moon. Now, they did not expect to crash land, but the way this thing was constructed, it's a glass disc that's been carefully etched. In the grooves, they were able to insert this material. It turns out they think that this glass box survived the crash. And if that's true, it was a last-minute decision, but one of the engineers got some tardigrades, which are a fascinating life form, which I'll tell you about in just a moment, wrapped them in basically NASA standard duct tape, wrapped it around the glass box, and that would have helped cushion the glass box during the crash landing. So this last-minute, spur-of-the-moment decision may have actually helped preserve the DNA samples that crashed on the moon in April. Tardigrades are fascinating because what they do when they get thirsty or too hot, too cold, they dehydrate, meaning they give up all their water, and they curl up, and they turn to glass. So remember, you have glass taped to glass, and the tape probably helped cushion the fall. These tardigrades, if we ever bring them back to Earth, or even just hose them down on the moon, they'll probably be fine. Because tardigrades are, to our knowledge, the most hardy life form. They will thrive anywhere, and you cannot destroy them in any way that we know we have tried. Yes?
What's the scale of a tardigrade?
Oh, these are microscopic.
And where do you find them on Earth?
Actually, they're kind of everywhere because they're so hard to kill. This particular picture is from a little bit of moss. And so another name for a tardigrade is a moss piglet. They're also known as water bears. So yes, you can find them in any watery area. They're kind of everywhere, but because they're microscopic, we generally don't think about them. But you've probably encountered them without knowing it. And if you've ever seen the movie, The Ant-Man and the Wasp, tardigrades do have a cameo. Any other questions or comments? Yes?
How did China grow the plants without atmosphere?
Actually, that's an excellent question. How did China grow the plants without any atmosphere? What they did was they had this in a little box about the size of a microwave oven where they did have an atmosphere, a small temporary one. And they knew that the atmosphere would dissipate if the little door was ever opened. But they did not crash land. They landed beautifully. So that little box is still there, still sealed. Yes, Carol.
This might be a real stupid statement. I'm going to say it anyway. What happens if you figure out a way to keep up with the light on the moon as it moves?
Mm-hmm. Oh, meaning if you had it on a rover and it just was able to move fast enough, yeah, things would keep growing. Life, once you get life established, it keeps going. It finds a way. And one of the things about experimentation, and this has been done on the International Space Station and elsewhere, is you take these things to extreme places, so outer space, Antarctica, inside a volcano, and you figure out what will survive. And there are some places on Earth, in California, there's the Salton Sea, which is one of the most salty places on Earth, and yet organisms thrive in acid, in salt, in bizarre places. And so you just figure out which life forms are going to live where. These tardigrades, we've put in all those places and they keep living. So that's you know, they are probably going to survive the end of everything. Oh, hang on. Right. So China has been normally, let me start that sentence over again. For those of you who have been to China, and there are some people in this audience who have, so you can tell me your stories, it's very hard to get ordinary people in China to talk about their space program. Even though there's a lot to celebrate. They have astronauts, they have space stations, they have successful moon missions. And you try to talk to somebody on the street in Shanghai, and no one will talk to you about space. It's not on the list of approved topics. But every once in a while, they are allowed to admit they have a space program and it's successful. So April 24th was Space Day of China. And notice that they put this in the American date system, not the European system. This is designed for Americans. And all of a sudden, you could talk to people again, but only this April. Carolyn, John, any comments? Carolyn.
Well, one of the things that I found out is not a lot of them know a lot about it. So when there was a mission that was going to the moon right at Christmas time, right after Christmas time, and I was actually out at a applied physics lab and waiting for the ultimate buoy mission. And I was watching on China Space, or China, it's a television cable channel, and they were broadcasting, but only to the west. And I quickly texted my translator, who I stay in touch with, on WeChat, and she said, "It's landing? I didn't know anything about it." And so some part of that may also be that they don't know enough about it. And the people who do know, they don't talk.
Right. Mike.
My first trip to China was to Hong Kong, which of course was originally a British colony. Hong Kong has a wonderful space museum, a really beautiful building where they have Chinese spacesuits, samples from some of their early space shots. Chinese spacecraft, manned spacecraft, are essentially the same as Russian. Their designs are all based on the Soyuz. And the museum was virtually empty. A lot of the interaction between Hong Kong and the rest of China has not brought in a lot of curiosity. There's a really different approach to how people absorb science and absorb education over there whenever it's anything that might possibly impinge on the national defense. And the space program is part of the national defense because their boosters were based on the Long March nuclear missile.
So there's a lot of self-censorship among the population of China. We are just not used to it here in the United States. So if anything, we overshare. Just look at your social media feeds. But in China, it's very, very different, which is why these Hong Kong protests are so interesting, because people are trying to express themselves, and the older people are terrified they're going to get invaded by China. It'll be interesting to see what happens. Okay, so we're actually going to talk about the Chinese lunar exploration program. And I just have to say, as an aside, this is a lovely logo. And I wouldn't normally bore you with logos, but look at this. They have a lunar crescent, and inside they have little footprints. And as it says, the symbol resembles the character for moon. So it's really, you know, when it comes to logo design, that's incredible. And by the way, for those of you who don't read Chinese, I do not read Chinese. If you ever see this symbol, this is the symbol for China itself. Notice it's basically the world spinning on its axis.
China is everything under heaven.
And this is a culture that's been active and thriving and scientifically literate for thousands of years. So when we do talk about the Chinese space program, we're going to spend most of our time talking about the Chang'e 4, which is the spacecraft that's on the moon right now, and we will answer Ben's question in a few minutes. What's interesting is that the person who founded China's space program was actually trained in the United States, and he was a victim of the Cold War. This is a young man who'd come to the United States to work at UCLA, to go to Jet Propulsion Lab and learn how to be an aeronautical engineer. And for reasons completely outside of his control, he got tagged as a foreign agent who had to be arrested and deported and sent back. And he's all the while going, I didn't do anything. But he got sent back, he was immediately imprisoned, his family was imprisoned, and they basically said, so you learned something from the Americans, right? We're going to get a space program out of it. And in fact, they do now. So von Karman was his PhD advisor, and Chang'e landed in the crater named for von Karman. So again, the Cold War has these weird echoes. So we're going to do a couple things that's a little more physical because you've been sitting for a while. So anybody who right now wants to just stand up and stretch, take a deep breath in and out and wave your arms, go ahead and do that now, please. Because it gets very tiring to just sit and listen. And then I'm going to bring up my husband, Mike, who is also a PhD. And come on up, Mike. We're going to get some volunteers so you can do a little science explaining.
Hello, everybody. Can everybody hear me all right? I don't have a microphone.
You don't need a microphone.
Well, no, I have to be able to talk over you. For those of you who don't know me, my name is Mike Metlay. I'm a former nuclear physicist. I'm now a rock and roll journalist. But I've done a lot of work in astrophysics as well, and I've been helping out Suzanne doing these bizarre little demonstrations of certain ideas. And she humors me and lets me come up and make a fool of myself in front of everybody.
He's good at that.
So, Ben, you had asked the question. Because Chang'e 4 landed on the far side of the moon, which until 1959, we could not see. How do we talk to it? And that is a very, very good question because the moon is 3,000 miles thick, so you can't send messages through. And the Chinese came up with a very ingenious way to get around the problem. Now, to demonstrate, I would like a few volunteers. 3 or 4, please. Ben, I need you. I definitely need you. Please come up. Anybody?
Yep, come on up.
Come more. Please, come on up. Come on up. All right, we'll see.
You've got 4.
Okay, you've got 4. This is probably good enough. Now, your name is Glenn, and you are Nancy, and you are Jennifer, and this is Ben. Okay, so let's see now. Glenn, if you would come over here, please. Stand right here. Facing that way. Glenn is an observer on planet Earth. Okay, he's looking out into space. Ben, you can stand right here. Right here. Good. Ben is the moon. Okay? Nancy, if you would, you're going to stand right in front of Ben. Okay? Now, Nancy is a satellite that has landed on the near side of the moon. This includes Bereshit, this includes Chandrayaan.
All the Apollo missions.
Apollos, all the surveyors, all the lunopods, everybody up until the Chinese landed on the near side of the moon. So what I'd like you to do, Nancy, is pick a number in your head between 1 and 5. Then I want you to hold your hand up in front of you and signal Earth. Okay? So go ahead and signal. Glenn, did you see the signal?
Yes, I did.
What was the number?
3.
Perfect. There you go. Data is successfully transferred across the 250,000 miles to the Earth. Now, if you would come over, please. I need you to stand behind Ben, facing away. Facing this way. All right? Now, I want you to think of a number between 1 and 5 and hold up your hand in front of your body and show the number. All right? So go ahead and do that. No, don't hold it up in front of your body. Now, show me the number. Glenn, what's the number?
I cannot see.
All right. See? You see the problem, okay? You're facing in the wrong direction. Chinese came up with a very interesting solution to this, okay? Does anybody here, aside from our volunteers, know what a Lagrange point is? Okay, a Lagrange point is, it's a place in space, all right?
We will have pictures to show you in a
Yes.
few minutes.
And that will help us along. But the basic idea is, you can imagine that if I'm here near the moon, and you're just to let me go, the moon's gravity would cause me to fall to the moon, right? And if I were here, close to the Earth, and you just let me go, I would fall to the Earth. Now you can imagine in your head that there would be some spot in between the Earth and the moon where the gravity of the two objects would balance out. And I would stand still. I'd be in one place in space. I wouldn't go in either direction. That is the Lagrange point, number one. Now, it just so happens, because of the mechanics of gravitation and celestial bodies, that there are actually 5 Lagrange points in any two-body system. There's this one, the obvious one. There's one way back here, where you actually get a balance this way. It's very unstable. That's Lagrange point 3. And then, out in the orbit of the moon, there are 2 more on either side, Lagrange point 4 and 5. Those are very stable. Lagrange points are fascinating because they're a spot that has no physical body. But if you send an object near a Lagrange point, it will orbit around that point in empty space as if there was a little planet or a moon there. And the Lagrange point that we're most interested in, well, up until Chang'e, the Lagrange point that astronomers were always interested in was L4 or L5. If you look at the solar system, you'll see that most of the large bodies in the solar system collect asteroids in those 2 spots. The Trojan asteroids are asteroids in the L4 and L5 points for Jupiter. And the L5 point was particularly important. You may have heard of the L5 Foundation. That was where they were going to put a space colony. That's where a lot of the early space idealists said they were going to build a big rotating station to create artificial gravity, and they would put it way out there because L5 would be stable and it wouldn't be in danger of being hit by it. But the Lagrange point that the Chinese were thinking about is L2. And L2 is over here, behind the moon. So they created a satellite called Magpie. And they put Magpie in orbit around L2. So watch this. Glenn is on Earth.
Jennifer.
Chang'e has landed, and Magpie is doing this. Just hanging around. So show me that number again. You talk to me, I can talk to Earth. Okay? And this was mind-blowing because the physics is easy, but nobody else thought of doing it. And the Chinese managed to put not only a lander, but a lunar rover called U2, which is the name of the mythological jade rabbit that lives in the moon in Chinese mythology. And U2 has been trundling around, and its successor, U2-2, have been trundling around on the far side of the moon, where the geology is very different than what we're used to, gathering incredible scientific data, all because the Chinese took advantage of a little bit of physics so that our jade rabbit could talk to a magpie, and the magpie can talk to Earth. Yes?
Are stereo A and stereo B on these Lagrange points?
I don't know offhand. I have to look. Any questions about this? All right, let's give it a hand for our
Our volunteers.
and then hopefully that answered your question.
All right. And now, John, if you want the microphone back, I'm happy to give it back to you. Okay. So John is going to switch to his presentation.
Hold on.
Yes.
I get my
Will work for kisses. Yes. Okay, and do you want the laser pointer?
I got one.
Okay. Do you want the slide advancer?
I'll do that.
Okay.
I'll take something from you. So yeah, I put this together as a news update, and then I went over to our website, which that was the right way to do it. Oh, she's talking about the same thing. Oh boy. So I'm just jumping up here. So yeah, the other side of the moon. So Chang'e 4. This is CLEP, Chinese Lunar Exploration Program. And Chang'e comes from moon goddess, so there's one that got one that they didn't get. And lunar lander U-22 is Jade Rabbit, like they said. Landed in the Von Karman crater January 3rd of this year. It's a 112-mile, for U.S. people, diameter crater. It was designed to last for 3 lunar days. Remember, a lunar day, 2 weeks of light, 2 weeks of dark. So that's 1 month. So 3 months is a lunar day. And it was returning interesting radar data. It's mapping subsurface features. It's taking a look at visible and near-infrared spectrometry to figure out the chemistry, because as he said, the backside is a very different world than the near side of the moon, geologically or lunarologically.
Selenologically.
Thank you. All right. And they're also looking at cosmic rays. They're doing a test of a low-frequency radio telescope, because the Earth is pretty noisy in radio frequencies. I don't know if anybody knew that. And so if you do get this massive moon between you and the Earth, you get wonderful shielding. So you can take a look out in the universe and not have to filter all the Netflix going through Wi-Fi. And take a look at lunar surface temperature measurements and even coronal mass ejection observations of the sun's activity. So Chang'e 1 did its thing in 2007, Chang'e 2, 2010, Chang'e 3 in 2013. 5 and 6 are planned, and they want to do sample returns. So I'll see, I bet you can get into that. And maybe in the 2030s, humans. So I'm sure you'll get into that too. Here's the graphical picture of what he just illustrated with the orbit around the L2 point and giving that nice wide view past the moon to be able to go communicating, and then the communication from there goes to the lander, can go to the rover. Pretty ingenious. So here's an image of its track over these lunar days, and they've been speeding up recently. They've really said, okay, well, let's have some fun. So they're doing some sand dune hopping, not really. Here's some tracks. Here's the shadow of the lander itself. Another nice image from the surface here. This is the rim of Von Karman crater in the background. We have the obstacle avoidance camera. I guess they had a problem early on that it was sending faults. There's something I'm going to hit, signals and stopping. And they were able to reprogram it and make its onboard version smart enough to make better decisions, which I wish I could get my 4-year-old to do. Here's a glare on the solar panel. You can see its little tracks. It did donuts here, because who doesn't? Looking at its own little tracks there. And this is a great one for me to pass it back on. Here's a picture of the Earth and what's going on. Anything unusual happening on the Earth? Solar eclipse in South Pacific in July.
Can you point that out with the laser? There you go.
So the shadow of this thing is right there. Wow, it just gives me chills. All right, back to.
Thank you, John. Well, I'm done. No, I'm just teasing. Yeah, amazing, amazing stuff. And we're only going to get more good stuff as the months go on. Because just like American engineering has proved the test of time, these missions that American engineers put together are supposed to end in 5 years, and they keep going 20 years later or more. Same thing with the Russians, same thing with the Chinese. So really excellent engineering.
Are the Chinese sharing any of the information?
Some, right? They're giving us these images, and we can pore over these. But yeah, the Chinese are much less open about what they share. With NASA, you get a data dump. You know, it's all raw data, and it's like, here, you go play with it. And the Chinese are only giving us certain things. Yes?
So if, it's in the orbit and it's sending the information back, couldn't we pick up those signals?
Yes, and I bet NSA is hacking them. Yes. John?
No.
Oh, okay. That is a very good point. Yes, and what's interesting is even amateur astronomers, there's an entire network of amateur astronomers around the world who, just for fun, these are all retired volunteers, will hack the Americans, will hack the North Koreans, will hack anybody who has a secret satellite launch that no one's supposed to know about. So of course these volunteers are all over it, and they're talking to each other. So every time North Korea thinks they're sending up something super secret, or they say, oh, our mission worked fine, we are blasting patriotic songs, and you have this guy in Toronto going, no, you're not. Pablo?
You were saying that China is not sharing much information, but let's also remember that the scientific community for quite some time was segregating China as well, so it goes both ways.
Yeah. Yes, it really does. And China has been the injured party, well, including now. There's still very little communication at scientific conferences. The Chinese teams keep to themselves. Okay, do we have an opportunity, John, to play some videos? So this is from January, and we're not going to show you the whole 2.5-minute clip, but this was Chang'e landing on the moon. And so what you see here in front, this is the strut, so this is part of the spacecraft. So is this on the side, and the lunar surface is getting closer. Now those are craters. They look like bumps to a lot of people, but they really are craters. And now we're going to start kicking up some dust.
Those wind effects are real wind outside. It's not when you.
There you go. And so that's from the thruster, allowing the spacecraft to land safely. And yeah, that's always just a marvelous moment. It's like when you're on an aircraft, right, and the airplane lands safely. It's that feeling. So now we're going to see U-22. Okay, the camera is on Chang'e 4, and it's watching U-22 do its thing. You can tell where the sun is because you can see the shadow. And you can see how thick the dust is on the surface because look at the wheel. You can see the track right here. And these wheels are about 6 inches wide, about. Notice that the exposed surface of the moon under the dust is always a little bit darker than the surface that's been effectively bleached by the sun. And so there we have the lander doing its little donut, just to prove it can. And okay, we're going to come back to this one, John, in a little bit. So let's go back to the PowerPoint. Any other comments or questions? Ben?
What's the rover do during the winter back to stay dormant?
Yeah, it just folds up its solar panel and it goes to sleep. And then when the sun comes back, it opens up the solar panel. And why does it close it up? Because that lunar dust, I mean, there's no wind to blow around, but you don't want to get hit by a micrometeorite or something and damage a solar panel. That would be bad. If you two would like to come on, we've got a couple of seats right here in the third row from the front. You're welcome to sit there, or other people can rearrange chairs. I leave that up to you. All right, so boy, I was going to talk about all this. I'll just speed through this because we got to all this stuff. The one thing that we didn't talk about is that this whole experiment about L2 was tried almost 10 years ago. And what happened was they got to the L2 point, and then either on purpose or by accident, I think it was on purpose, they decided, you know, we proved we can get to the L2 point. The spacecraft is still healthy. Let's go find an asteroid. And so it did. It went and checked out Tutatis. And this asteroid, you know, not all asteroids are in the asteroid belt. So this was an asteroid closer to Earth. And then it left that and went on a deep space mission, and it's still on its way to wherever. So yeah, the Chinese have had some of these missions in mind for a while. So you've seen that, and you've seen that. So yes, this sample return, the T1 will be the sample return vehicle. So it'll be the Chang'e 5 mission, and only the T1 will come back to Earth. Okay, so when we've been talking about these things, I should have thrown up a map. I should have had a map of all the near-side landings locations, and I meant to put that in, and I didn't, because I forgot. But what's really fun is when you look here, notice that Crater Chrétien has little Mickey Mouse ears. So if you look for Mickey Mouse, and then you go just a little bit over, you'll find the Fun Carmen. What was that?
That's a great hidden Mickey.
That's right. All right, so this is what Mike was talking about. Here's the myth of the two lovers who were not allowed to meet. So the birds, the magpies, built a bridge so that the lovers could communicate. And one of the lovers was the moon goddess, Chang'e. So that's where this whole story comes from. And, you know, the thing is that even the Chinese have difficulty. And there were actually going to be 2 satellites going around that L2 point, but only one of them actually got where it needed to go. So even the Chinese have errors. So I know this is incredibly hard to see, but you'd seen the little map that John showed you. Well, here's the Chang'e. Here's U22, or at least where it was in May. And if you can see right here, this little dark line, that's its track. So the American Lunar Reconnaissance Orbiter can, in fact, follow U22 as it trundles along. Isn't that amazing?
Good practicing anywhere.
All right, so as we said, Jade Rabbit, U22, sometimes has to go take a nap. And they make these little cartoons for the regular populace. You know, part of it is the culture. If you've ever heard of K-pop, Korean pop, or J-pop, Japanese pop, cartoon characters are really, really popular. Same thing in China. So you can tell this is made for Americans. It's in English. But this is part of their propaganda to us. And yeah, when I made the slide, it was for June, but as John pointed out, we're now in Lunar Day 8. And so we don't have any information, we don't have any images from Lunar Day 8, but we do know that everybody's healthy and working okay. There were some glitches in Day 6 and Day 7. Things have not been working perfectly, but they fixed them, and Day 8 seems okay. So in a couple of weeks, hopefully we'll get some more images and info from China. I'm a planetary geologist by training, so obviously I care about the dirt. And the dirt, the soil, or officially the regolith, on the far side of the moon is in fact very different from the near side. And what's so interesting is this implies different things about the origin of the moon. And there are several different theories as to why our moon is so big compared to Earth, why it's lopsided. It is. Even the core of the moon is a little bit off center, and it's a little bit closer to Earth than it ordinarily would be if it was just a body that formed like any other body. So there are some ideas as to why that happened. Some people say, well, the moon completely was molten and it formed an Earth's gravitational field, and that's why everything's off center. I personally don't buy that. I think, and remember, I'm not a lunar geologist, so I could be entirely wrong, but I like the idea that there were actually, for a while, well, let me backtrack. The way we, and by we I mean the planetary science community, generally think the moon formed was there was a Mars-sized impactor that when Earth was very young, just a couple of hundred, if that, maybe even just 100 million years old, when it was very, very young, Earth was still pretty much molten. It was starting to, what we say, differentiate. The heavy stuff was sinking to the inside to form the core, and the light stuff was floating up to eventually form a crust. If you've ever made a pot of soup, especially a chicken soup where there's a lot of fat, you know that if you let that get really, really cold, when you look the next day, all the potatoes and turnips are at the bottom, and on top you have this crust of fat. Well, a crust of a planet or a moon is the same way. All the light stuff floated up and then froze in place. Well, before that could happen, while the pot of soup was still pretty warm, this Mars-sized impactor hit Earth. Now, it didn't hit directly on, or we would not be here today. But it hit a glancing blow and splashed out a lot of stuff, most of which fell back to Earth. Now, this impactor probably vaporized, meaning it turned into a gazillion little bits, which then mixed and fell back to Earth. So most of that is probably still here on Earth. But enough formed basically a ring around Earth. And the theory that I like best right now, although give me another NASA press release and I might change my mind, is that these objects orbiting Earth collided and stuck. These were gentle collisions. So they didn't break each other apart, they glued together. And it could very well be that the moon did have a nice central core the way it should have, and one of the last impactors just enveloped it. Think of a strawberry being enrobed in chocolate. And it could very well be that the far side of the moon looks really different to us chemically because it was a different object enrobing the other. So we'll see. That's just one of many ideas of why the moon is the way the moon is. Pablo.
Can you talk a little bit about how the far side is different to the near side, or you want to park in love that one?
I will give a very quick. When we look, let me see if I can go back. There we go. Do you see how this looks kind of light colored? As opposed to what we normally think of for the moon. There we go. We normally think of the moon as having lots of dark craters, like this Aitken crater. You see how it's noticeably darker? Here's another dark patch. The near side of the moon has a lot of these very, very dark pieces of rock facing us. You know why it's dark? It's made of basalt. The exact same stuff you find in Basalt, Colorado. Or if you go to Home Depot and they don't lie to you and call it granite, they will actually show you a piece of gabbro or basalt. It is the same stuff. Meaning the most common rock on Earth is also the most common rock on the moon, at least on the near side of the moon. It's also the most common rock on Mars and on Venus. Basalt is really, really easy to make, and it's everywhere in our solar system. Everywhere. Because basalt is just bug easy to make. So the near side is really covered in a lot of basalt, which is high in iron and magnesium. There are some other chemical elements. We know of stuff called creep, but most of what's on the near side of the moon is very low titanium, very high iron. When you go to the far side of the moon, Now it's mostly covered in this light stuff that we call highlands. Okay, the dark stuff is clearly from volcanic activity, just like basalt on Earth. This highlands stuff, that's the fat that floated to the top of the chicken soup and froze in place. And this is very high in titanium. This is very high in potassium and stuff we call rare earth elements, and phosphorus, so creep, K for potassium, REE for rare earth element, because it's rare on Earth, and then P for phosphorus, so creep. And there are other chemical differences, but basically this is light and fluffy as opposed to basalt, which is dark and dense. So that's the quick answer. You okay with that? And we call this stuff mainly anorthosite. You can get anorthosite on Earth. It is a very rare form of plagioclase feldspar, so anorthite. And the rock is called anorthosite, because why not make it more complex? Oh, wait, I wanted to go back here. So what they're looking for are these chemical differences. They also want to see, well, if it's made of different stuff, does it hold on to heat differently? The short answer is yes. Does it have any H2O content? We don't know, but I'm sure they're going to tell us if they do find water. And is there anything else interesting? Well, yeah, it turns out that some of what was exposed that they've looked at seems to be deep mantle material, to which everyone who's a geologist goes, ooh, how did you get that? Because the only way you can expose something under the crust is to punch a hole in the crust. Well, the moon keeps getting hit by impactors. So it could be that there was an impact somewhere and this stuff got thrown over here where U22 can sample it. So they have to then figure out, well, which crater can we associate with that impact? So this is going to lead to a lot more work, which, yay, work. Okay, so this is going to be the end of the China part. Yes, you guys can read the cartoon. For those in the back, you can get Manchurian beef, vegetable chow mein, beef chow mein, and shrimp. So that's your Chinese carryout. Nothing culturally inappropriate there, huh? Okay, so now we're going to switch over to Israel. And rather than having me talk, why don't we put on the video of what Israel was hoping to do. But before we do that, does anyone have any last comments about China?
What was the YouTube channel that those were on? Public channel?
Yeah, I don't go to any special secret sites. It's all available. Planetary Society and various others. Yeah, you'll be fine. Okay, John, go for it. So this was a little bit of propaganda put out in March because they were getting all excited about Bereshit leaving Earth and getting into the orbit of the moon. And as Mike said, it doesn't take much. You get into the vicinity and you get pulled in by the moon's gravitational pull and you go into orbit. And you make these lovely loop-the-loops. Now they were very worried actually that they would miss the moon. They did not. They were actually doing really well. They got into the moon's orbit successfully, and a week later they tried to land. They did not miss the moon. What happened was they had a glitch, and that was just long enough to not slow down its velocity, so they hit hard. So this was what was going to happen. Okay, what was going to happen was they were going to very gently land on the moon, just like you saw the Chang'e 4 land gently on the moon. And then the Israelis were going to have their own little, well, they were going to jettison its lunar library, that little glass library I told you about. And then they were going to take some samples right where they were, and then send out a little rover, which was going to trundle over, and for one lunar day, take samples someplace else, and then send all that data back. They were not going to send any samples back. The whole idea was to bring some of human art and intelligence in this little etched thing to the moon to stay there as a repository of human knowledge. They even had a little instruction book on, hey, aliens, if you find this, this is how you can read it. And they even put in a magnifying glass. They basically downloaded all of Wikipedia. As I said, they had DNA samples. Because this is Israel, they had a copy of the Torah, the Talmud, and the Mishnah. I mean, the whole bit. So all of that's there. Also, they were incredibly proud. So I don't know if you can see this. This is an Israeli flag. And in Hebrew, it says, the people of Israel live, small country, big dreams. And then they give all the logos. Here's another view of the logos. The whole reason this thing started, this Bereshit mission, is because of this Israeli Elon Musk, Morris Khan, who said, and yeah, come on over, have a seat wherever you can find one, who said, you know what, this is a great opportunity for our tech sector, but also for STEM education, for science, technology, engineering, and math. Let's get the kids all excited about this. So they would actually have these little lunar mock-ups, and it would go to various cities and rural areas in Israel, and there would be school field trips where they would talk to the scientists and the engineers, and it was very much a recruiting drive, basically saying, look, you're in 8th grade now. In 5 years, come give us a call and we'll give you a job at Israel Aerospace Industries or in the Khan Foundation. Space IL is a nonprofit for education, for science education. So basically they're in the middle of a recruitment drive. And in fact, as we know in the United States, when there was Sputnik in the beginning of the Apollo program, a lot of kids did get interested in science and engineering. A lot of you grew up and are in this room right now, right? How many of you were inspired in the late 50s, early 60s to go into science because people were going to the moon? I see some hands, yep. So, you know, this is why the European Union and Japan and India and Israel are interested. But what's unique about the Israeli mission is that there was virtually no government funding. There did have to be approval. For example, in the United States, if you want your spacecraft to launch, you need approval from the Federal Aviation Authority, because you have to go through airspace before you can get into space. So you need approval from the civilian air authorities. So Israel had to grant that kind of stuff. But the rest of this was done privately with donations from the Adelson family in the United States, the Khan family, and various others. And Peter Diamandis, I don't know if you know him, he's the guy who invented the X Prize. It then became the Lunar X Prize, and then Google got involved, so now it's the Google Lunar X Prize. There's a lot of money at stake. So they had this competition and said, hey, anybody who can privately build a spacecraft and land it successfully on the moon, we're going to give you $10 million. Now, of course, it takes like $100 million to do this. But that's okay. Incentives. Well, in May 2018, they said, no, nobody did it, no winner. And Morris Khan and his buddies in Space IL said, well, you know what, we're going to go ahead anyway. We don't need the $10 million, that's pocket change for me. So they decided they'd go ahead, they got a few more corporate partners, and then, yeah, they launched using SpaceX, which is Elon Musk's company here in the United States. So even the launch was private. Everything was private that they could possibly make private. And yeah, they did have some glitches, but everything looked good until, of course, it didn't. Oops. So what happened was the main engine temporarily shut down. It got a, oh, you're moving too fast, cut the engine signal. And of course, that was the wrong time to turn everything off. So when they finally turned everything back on, they were still going too fast. But they did actually make contact with the moon. And the people at X Prize said, you know, technically, so X Prize gave them $1 million anyway. So, oh, and this is what they were going to do. They were going to check out the moon's magnetic field, and they were going to put a mirror on and stuff. Well, anyway, so Morris Kahn, this is him, the very next day said, you know what, we're going to go ahead and we're going to create Bracesheet 2. So the work today starts for Bracesheet 2, is what this says. And that was April 12, because they crash landed on April 11. And by June 26th, there came a press release saying, you know what, we're actually not going to go to the moon. And everyone was like, they're not going to go to the moon, what are they going to do? Well, 2 weeks after that, on July 9, they said, we're going to partner with this little company you've never heard of out of Cedar Park, Texas, and we're going to become part of the United States lunar program, what is now becoming known as the Artemis program. Artemis was the twin sister of Apollo. So the Apollo mission sent the first men to the moon. Artemis is going to send the first American woman to the moon. And men, but so that's interesting, because now we still have this Bracesheet lander. They sold the tech. They are renaming the American version Genesis. Bracesheet, by the way, means Genesis. In the beginning is what it officially means. So they still have the money and the tech and the engineers and the science. Everything's in place. So we're waiting for the next tweet or press release to find out where Bracesheet 2, which is in construction right now, where it's going to go. I cannot tell you where. They have not told us. So stay posted. Any questions or comments on the Israelis?
Exciting times.
Yeah, and notice this isn't really an Israeli mission. This is really a private sector mission, right? It just happens to be based in Israel. But this could have been based anywhere around the world. Okay, so now let's talk about India. And we are getting very close to the end of my talk. So thank you very much for your sitting. The scary thing about India is that they, like Israel, have been very quietly developing an excellent high-tech sector, right? And you know, because you've talked to a lot of call center people from India. But they've also been doing some world-class engineering. And for those who follow the industry rags, it's been impressive stuff. That having been said, it's hard to go to space. And so they were also going to launch something in April, and they had to delay because while they were testing one of their components, during a routine drop test, they did in fact drop their lander and damage 2 legs. So they had to repair it, and they had to, okay, so finally it got off the ground last month. I mean, it's not even a month ago. This is August 16. And this was launched on July 22nd. So it's on its way. It will probably, the Chandrayaan-2, by the way, Chandrayaan is also a moon goddess. This Chandrayaan-2 spacecraft will probably get into lunar orbit next week. We're looking at August 20 or 22nd. That's less than a week from now. And then they're hoping that on September 7, they will have a successful landing. And that means India will be only the 4th nation to soft land on the moon. Remember, the Russians did it first, then the Americans, then the Chinese. The Israelis crashed hard, so they don't count. And so India is hoping to be number 4. And that is going to mean a lot for them because they already demonstrated they can do good work with their orbiters. They found that there is, in fact, water ice on the moon, and ice can of course be melted to make water that astronauts can drink. More importantly, it could be cracked into oxygen and hydrogen, and you don't have to work that hard because sunlight does that anyway. There are these little oxygen molecules that really do, every daytime, kind of wake up and go, oh, I have energy, I can move, I'm gonna leave the lunar surface, I'm so excited. Oh, it's nighttime. Oh wait, it's daytime again, right? And so we can't say that the moon has an oxygen atmosphere, but it certainly has a lot of oxygen and hydrogen, which is even lighter and easier to move around, moving around. Well, if you want to make a fuel out of hydrogen and oxygen, this would be a good place to go. This South Pole region that seems to be full of ice in deeply shadowed craters. So this Vikram lander is named for one of their best engineers. I don't want to even attempt his last name because I don't want to mangle it. But in honor of one of their top engineers, the Vikram lander is going to hopefully, okay, you can't read this, is hopefully going to land in a high plain between two craters, Manzinus C and Simpelius N, at a latitude of about 70 degrees south. No spacecraft has ever gotten to such a far south position on the moon. Oops, did I accidentally close that? If I did that, I apologize. Yeah, because I'm almost done. So if they miss that site, they're going to land at 67 degrees south, which is no big. But they've also never gone as far south as 67 degrees. And for those of you who are like, I don't understand, what do these numbers mean? When we look at Earth, you guys know about the equator, right? Oh, maybe I should put it on this side. Okay, so we know about the equator. If you think about 66 degrees north, that's what we call the Arctic Circle. And if you go to 66 degrees south, you're at the Antarctic Circle. So this is the equivalent of going past the Antarctic Circle of the moon. So that's an analogy. But does that make sense? Okay. Well, I didn't have much more to say about, oh, excellent. Thank you. I didn't have much more to say about India because their good news, hopefully, will come next month, and then we'll have a lot to say. But you can read about that on your own on the news. What I did want to say is, so here's the lander, and it doesn't look like much here because it's all kind of mushed together. So here's a schematic of this lander. And you can see the solar panel, again, pops up. So during that lunar day, it gets its sunlight, and then you can close the lid for night. So it's a very clever design. This is directly in competition with what the Americans are trying to do. Or I should say, the Americans looked at China and India and Israel and everybody else and said, well, we should go back to the moon. And through previous administrations, lunar manned missions have been floated and then killed in Congress because it's too expensive. Or Congress would allow a little bit of money to develop a crew vehicle. So the Orion crew vehicle has been in development for like 15 years, right? We still don't have it. So finally, the current administration said, look, we're going to do everything commercially. We're going to give contracts and subcontracts. You guys in the private sector, you figure it out. And once you figure it out, come back to us and we'll send you up. Okay, bye. We got an Artemis program. We're good. So that's the state of things. Now, just today, Jim Bridenstine, the NASA administrator, had a big press conference at Marshall Space Flight Center in Alabama to announce that that's going to be the new hub of astronaut missions for this Artemis program. And the entire Texas congressional delegation, Senator Ted Cruz and others, protested. And they said, but wait a minute, astronauts have always come out of Johnson Space Center in Houston. This should be a Texas thing. And NASA said, nope. President Trump told us to move it to Alabama, so we are moving it. I mean, you can still have a piece. There'll still be some work at Johnson Space Center, but we're going to move it to Alabama. Well, that, of course, is all political. And for those of you who remember the Apollo program, if you wondered why Johnson Space Center is in Houston, Texas, and Marshall Space Flight Center is in Huntsville, Alabama, it was to make the senators in the 1960s happy and voting for continued funding for Apollo. So this again is to get congressional delegations voting for funding the Artemis mission. There are some other aspects as well that I'm not going to get into now, but stay tuned. A lot of this is going to the private sector because Congress won't fund it, and a lot of this is jockeying for position in Congress. So this is political, meaning this is just like the Apollo program of 50 years ago. So we'll see what happens. But I'm excited to see all of this private space development, because you know what? Once a private company proves they can do it, just like the Israelis, Morris Kahn and all of those private companies he's been working with, they can go anywhere. They don't have to work with a government who won't fund them. There are private funders, and there are others who will partner with them. So that's, I think, the exciting end, because it's not really an end. We're in the middle of this space race, and it's exciting to see where we'll go. Thank you very much, everybody.